All right, so number one. You sure you don't want colored pencil, Sally? All right. Okay, so number one. So we got a swirl that's going down this slide. Incidentally, I'm pretty happy with my janky Photoshop job. That swirl was not on the slide. I put them on there myself. Right? Yeah, dang. That's what I said. Mad paintbrush skills. All right, so here we go. So those are supposed to be arms and ears. I don't know. Okay, so the problem tells us his mass. It tells you he runs at some velocity up here, and he goes down the slide that's 2.5 meters tall. Now, eventually, so his whole path is going to be this, right? So eventually, he's going to hit the ground, right? So my strong recommendation to you guys is when you solve this, call the ground 0. Okay? That means the end of the slide here is going to be a height of 0.5, and the top of the slide is 2.5 meters. There are other ways of doing it, but to me, that's the safest route. Fair? All right. Now, the problem also tells us that the velocity when he gets to the bottom is 3 meters a second. Good? So, at this point, again, you kind of autopilot. So, at this point here, if you calculate your total energy just by doing GPE and KE, you get 6.58 joules. Everybody good up to there? Okay. Now, up at the top, I can find my GPE. It turns out to be 17.15. Is my total energy still 6.58? No, it can't be for two reasons. One, you'd have to have a negative kinetic energy, which can't ever happen. Okay. Two, there's friction. There's a non-conservative force. Their total energy has to change. All right? So, as he goes down the slide, there's friction. So the force of friction is 2 newtons. The displacement is 6 meters. They oppose each other, right? So that work from the friction has to be negative 12 joules. Yeah, there's a bunch in that glass cabinet up there. All right, everybody good up to there? All right, I want to make sure you guys understand the importance of this negative sign here. So mathematically, the reason it's negative is because the force, the displacement was down and the force is up. So one of those is negative. Conceptually, what does it mean to have negative work, you guys? You're losing energy. So what that means is, on the way down the slide, I lost 12 joules of energy. How much did I start with? 6. So that means at the top, I must have had 12 more, right? So 18, right? Point whatever, right? Now, if you prefer to do it using math, that's cool. It's just this. Oh, it's just this. Our work is negative 12. TE final, 6.58. You good out? So if you solve this, you subtract the 6.58, and you get negative 18.58 equals negative TE initial, and the negatives cancel. Follow? A lot of people mixed up this algebra. A lot of people had plus here instead of minus, which is weird. Okay, so what that means then is that up here, the total energy's got to be 18.58. And now what can we do? Find the kinetic and use that to find the velocity, right? Follow? Okay, so if you do that, it ends up being like 2.02 meters a second. Cool? All right, and then finally for part B wants to know the velocity when he hits the ground. So again, why is this different from part A?
Because only force, no energy is achieved.
Yeah, because between the end of the slide and the ground,
It's only gravity.
it's only gravity. So my total energy should be constant at what number? 6.58, right? So that means the kinetic energy has to be 6.58, and you find the velocity. And then solve for your mass or your velocity, and it turns out to be 4.34. Cool, you guys? Questions? All right, I'm going to shut up. If you have